So let me start. So we started our discussion on the previous breakout by trying to enumerate a few of the challenges that can be improved by in the future. And we discussed that there is a need for having a common ground for researchers in both fields so that research can move faster or reduce the training period. We have also discussed, especially in which was my experience coming into biology, is that there are difficult terminology and what biologists often call mathematical model is really a description of the biochemistry that goes on inside the cell. And for someone like me coming from electrical engineering to understand that biochemistry took a long time. We also discussed that it's important to talk about to define what is a model, to come up with a definition of a model that would work for everybody, if that's possible. Another thing that we thought it was important is that we should be as open source as possible, making data available, making code available. Do not try to go for patents right away so that we could move faster. Which is certainly the approach that people have been taking with machine learning. With the machine learning literature is one of the big successes, I think, in that field is that almost everything is made open source. What else? So... Sorry? Okay, so I don't. I'm. Can I just skip that? I don't think I'm the best person to talk about the program in Germany. I'm sorry. So how could future generations adopt the ICCT stance, and how engineers could approach biology? Well, we agree that we should try to interact more with each other, right? Familiarize yourself with each other's fields. Go back to the fundamental papers, to the original papers, read the methods. Try to learn how the data is generated is very important. Go to that. This is very difficult for me to go over that part of the papers, but it's really important. One of my approaches to that problem was to actually, since I'm doing the modeling, I went to the lab and I tried to follow what they're doing in the lab and familiarize myself with those techniques, even though I'm not the one performing them. We also think that it would be really useful if students took a course in philosophy of science, and also to take more courses from other disciplines and majors to build vocabulary and foundations, and that biologists should be more proficient in math. I mean, I'm not the ones saying that. It was something that we discussed in the group. So I'm not trying to lecture anyone here. Sorry about that. So there is a number of textbooks available. So here we named a few that were suggested, which are introductory books in both areas. So there you have it. So this question number 4, can life be defined through this ICCT paradigm? Well, this is a very hard question. So there is there have been some attempts to try to explain life, but you know, in general, to be able to try to do that would be to oversimplify the problem. Although some holistic view and with assumptions and simplifications are possible, but this is still a big challenge in general. On the 5th point, can we identify and prioritize milestones for the development of a unified ICCT model? First milestone would be to promote multidisciplinarity, have the communities talk to each other, understand this the difference between the arguments involving equilibrium versus non-equilibrium states. And one of the things that came up a lot about here in this workshop was the idea that the relationship between information theory and time and so on. I think that should be resolved and understood. That we should be able to agree on that issue. So finally, for the generation of a nationwide center in ICCT biology, that would be a great idea. And one of the things would be to motivate people to work on these types of problems would be to have prizes for biologists who use ICCT techniques. And I think that works also, that would also work on the other direction, right? To have establish some kind of a prize for people who achieve remarkable theoretical and experimental advances in that multidisciplinary field. And more conference sessions on both areas. Right? I know I've been part of the communication conferences, in the biology sessions in communications and control conferences. Unfortunately, I have never been to a biology conference, but I would love to give a talk about my work there and see if something resonates in that community as well. So there you have it. I think that's all we discussed. Thank you very much.
Biology, or just for the general information theory community?
I'm not. I'm sorry. I just wanted to say that I'm not an information theorist, so I'm not qualified to address that issue.
You will. You will. I will. I think this.
Oh, sorry.
I think this remark came from me. My understanding was that the NFS had in mind to, when they designed the framework project, to have a bit of timeline. What should be a milestone? When should you internally, inside NFS, take decisions? What the further orientation will be? I heard that you have project durations of, say, 10 years or something, pretty long. Or am I wrong? Depends. I don't know. I mean, I have the German timelines are much shorter. You typically have maximum 6 years, and you have it like split into 2 or 3 years intervals. And the idea would be, in a certain time, say 2 or 3 years, you could have an idea what parts of biology, genetics, neural science, whatever, makes sense to look further, and you can trim your project a bit. But I would still leave the door open because there are new things coming up that might still be interesting. So I would not close the door, but I would say for you as an organization, it might make sense to trim at some point, have a decision point. This was my idea at that point, but otherwise designing milestones in that short time, and we had a few minutes, this is impossible. I mean, I know how long I need to define milestones for my own project proposal, not in 10 minutes. Okay?
Right, so you know how everybody's been, not everybody, whatever, there seems to be some concern about how information theory accommodates the variable of time, right? Timing, yes, and so she's asking, is that specific to biology, or is that a general information theory problem?
Well, I would say it's not generally absence of time. I mean, you can... Yeah, but I mean, you can have Markov models behind, and you can still do entropy for Markov models and things like that that have a notion of time. It's not totally gone. But of course, there are, when you look at time sequences, then you are ending up also moving into control and similar topics, dynamical systems. This is not information theory as per se, so you have to also take other neighboring disciplines, which doesn't hurt actually in that respect.